last example from this unit. Okay, so instructions are given here. If you are understanding the concept, you can solve with me simultaneously. Okay, can we solve it? Yes. Start with test. What is test? Test is what? Symbol,
Symbol.
literal, symbol.
Symbol.
Symbol, ma'am.
Okay. So, but it starts from 0. We are adding or not adding, no matters, but let's add it. Test. Okay. Start 0. Okay. So, start 0. It starts from the 0. All the pseudo instruction starts from the 0. I'm adding here. Now, begin. Begin is again my
Symbol.
symbol. So, I'm adding here. Okay. Next, next one is what? You can also add like this. Okay. Let me check the example. Yes, correct. So this begin, it is a branch and link instruction, and here it is given as the register number value as 15 and second operand value as 0. Okay, so what we are writing here, we are writing nothing. BALR ends with R. This is
R.
RR kind. Yes, very good. RR kind of instruction. Initially it is 0. Okay, for the next location counter, you have to increment the value. Okay, now what this using instruction says, using instruction is the value of the base register. Okay, so let's move on to the base table. My register number value is 15. Okay, and what about the content value? Now we can understand the content value here. Content value is what? Begin plus 2. What is begin? Location counter, it is 0. Okay, plus 2 means 0 plus 2, that is 2. Okay, so
2.
content of register, it becomes 2. Okay, in first case it was 0 because only star was given, right? So we have completed with this. So for better understanding, you can write here the location counter value is 2 now, right? Now location counter value for the next is also 2. This is once again the alignment, right? I'm aligning it for the SR instruction. Now tell me, what kind of instruction is this? Whether it is RX.
RR.
RR.
RR,
Okay,
ma'am.
yes, very good. So I need to increment value by 2. That is
2.
2 plus 2, that is 4. What is L? L is
RX register.
RX kind of instruction. Okay, so I need to increment it by 4.
4.
4.
For next, tell me,
RX.
12.
right? For next, yes,
RX, ma'am.
16. Okay, RX kind of instruction. For next, again,
20.
RX.
okay, for next, it is 24,
24.
right? Now, for next, again, BCT, it is also RX kind of
RR, ma'am.
instruction. No, no. I'm talking about
RX.
BCT. Okay, BCT is
No.
the, yes,
RX.
28, right? And now, which value is encountered? LTORG. What about LTORG? LTORG is which kind of instruction? It is pseudo instruction,
Sudo.
right? So we need to add that pseudo instruction in this table, pseudo upcode table. Okay, and here we are having the address. So here I am adding the instruction. So initially it was start. Okay, start is always 0, no need to mention. Using was the pseudo instruction after that, and I am getting LTORG instruction. Okay, so write it as it is. Now tell me, what is BR? BR is RR kind of instruction. Okay, RR kind of instruction. So what is the address of this LTORG? Can you tell me? 28 plus?
30, ma'am.
Very good. 30. Okay, so LTORG is having 30. Now tell me, is there any literal available before LTORG? Yes. How many literals are there? How many literals? Yes, everyone. How many literals are there at operand 2 column? 1, 2, 3, 4.
Three. Three,
Very
ma'am.
good. 3. So copy it in the literal table. This is my first literal. This is my 49 is my second literal. And this F4. All of them are full word. Okay. Right?
Yes, ma'am.
So I have added in the literal table all the literal values. Did I miss any symbol? So let me check it. Test is given there. Begin is given there. Yes. So everything is given. Okay. Now what will be the address of literals? What will be the address of literals in the literal table? Okay. What we have to do? Now tell me whether 330 is the multiple of 4 or not. 30 is multiple of 4 or not?
No, ma'am.
No. So what is
No,
the
ma'am.
next value which comes near the multiple of 4? Why? Because f is the full word. After 30.
20, 32.
Okay. So this is the address of the literal we need to assign. We are not assigning value 30 as it is here. As this is our full word, did you remember this part? I've just shown you alignment. Okay, multiple of 4 because it is the full word, right? So we have to take the next value. After 30, 32 is the multiple of 4. Okay, now once again we have to increment after that. 32 plus 4, 36.
36.
36 plus 4.
40.
40.
Okay, so we are completed with the literal table. Now what is it? Whether it is relative or absolute, we have to check. Okay, whether it is relative or absolute. It is relative. L is relative. A is also relative. A is also relative. So write R, R, and R. Okay, so we are completed with the literal table. Okay, now let's move on to the next statement. Okay, here after that 30. After 30, what is the next instruction we have to use now? Okay, after 30, the next instruction should be, you can see 32, 36, 40 is already done. If you remember LTURG, we have assigned addresses to all the literals. Now we have to increment. F is the full word. Okay, F is the full word. What is the next location counter here? 44. Okay, I should write here first. Then I need to align it. Okay, 44. And the last one is what? Once again, it is of full word 48. That's it. Once you are done with the location counter value, then you can easily go for the pass to phase of the assembler. Okay. So if you are if you are having any doubt, you can ask me, because this is very much important part. Okay, we have done all the alignment there, right? So let's go for it. Okay, now what is missing? Pass-through phase of assembler. Now, during pass-through phase of assembler, what we need to write, here we are writing the relative location. Okay, whatever locations we have calculated here. Okay, here I am adding the relative location. Okay, so copy as it is all the relative location from the actual instructions. Okay, from here. So I am copying here 0, then 2, okay, then 4, sorry, no for using. I'm talking about only this part. Copy this. Okay, this is our output. 0, 2, 4, 8, 12, 16, 20, 24, 28. Okay, after that, what is encountered? LTORG is encountered, right? So we need to check the LTORG literal addresses 32, 36, 40. Copy it. Okay, from this point, copy it. That's it. Okay, actually, it will be like this. Okay, 32, 36, 40, 44, and 48. So I have copied all the relative location in the first column. Now I have to go for the code. Okay, just go through the part that I have mentioned here. Okay, you need to read all this thing. Machine code for RX and RR, we have to set the offset value and how we are calculating the offset value. Okay, so if any content is given, in the base register, then we have to calculate the offset value. Okay, in the previous case, in the previous example, no content value was given. That's why here we have written 0 comma 15, 0 comma 15 likewise. But here content value is given, so we have to calculate the offset value. So how we are calculating the offset value? So let's start with the BALR instruction. We'll take this example and we'll finish. 15, okay, comma 0. Right, 15 comma 0 as it is, because this is the base register value and 0 is the constant value. Now next is what? Here, SR instruction. Okay, for this relative location 2, we are having SR instruction. What is the first operand value? 4. Second operand value is also 4. Okay, no half word, full word, double word was given. That's why I have written as it is. Okay, the next thing now. 4. At 4, we have given what? Okay, something I'm missing here. Yes, instruction name. Sorry, instruction name are also there. Copy this here. Yes, BALR instruction as it is we need to write. BALR instruction. (15, 0). Then next instruction was SR, right? After that, load on location 4. Then constant value is 3 as it is. And what about F equal to F10? Okay, what is equal to F10? Equal to F10 is the literal value. Okay, this is not a symbol, this is the literal value. So here we should write the value, offset value. Okay, so how we are calculating that offset value? First of all, base register value is what? 0 comma 15. As no index was given here, that's why here we have written like a previous example. Okay, आपण कसं लिहिलं इथे कसं लिहिलं होतं? So 0 comma 15. Same, we need to write here 0 comma 15. But what is the offset value here? This literal f equal to 10. It is having some value given, relative value given. And what is that value? This is 32.
32.
Okay, now how we calculate it? Offset value? Value of the symbol or literal minus the base register. Okay, minus the base register. So 32 minus, so I am writing here like this, 32 minus what is the base register content? It is 2. Okay, so it becomes 32 minus 2, that is 30. Okay, for your understanding, I will write like this. Actually, address is here 30. Now, next is what? L. Write it as it is. Okay, next is 3. Write it as it is, comma. Now, data 4. Okay, what is this 4? 4 is the index value. So, before writing the offset, I will write the index value. 4, comma 15. Yes?
3 का वेळ घेतलाय?
कुठे? Hey. Sorry, 2 असेल, 2 Yes. Okay, 4 comma 15. Did you get? This 4 is the index value. So index value comma 15. 15 is the register value. What we have to write here? Data. What is data? Data is the, I have not written anything here. So data, then what was there? Test, begin, data. Okay, values are, for test it was 0, for begin it was 0. Okay, for data it was, I think, 44. Yes. Okay, all of them are relative. So what is data? It is 44. Okay, so how I can write here? 44 minus 2. 44 minus 2. Okay, are you getting me? I know in first attempt it might be difficult, but you can ask me if you have any. So this is the thing. 44 minus 2, that is 40. 40 is the location here. Now next instruction is A. So I will write, you will understand. Next instruction is A, 2 comma F49. What is F49? F49 is 36. Okay, so I will write here 36 minus 2. Always 2 is the base content. Okay, 36 minus 2. And is there any index given? No. So 0 comma 50. Okay, now next instruction is ST. What is data? 2. Okay, tell me how I can write data like this. Okay, so same line should be repeated here. 44 minus 2, 44 is the address of the data and 4 is the index given and 15 is the base register. A 4. Okay, now what about the literal value? Tell me, literal value of equal to 4 is 40. Okay,
40.
40. So it becomes,
40 minus 2.
okay, so 40 minus 2 is, yes. Okay, and 0 comma 15. Okay, now this is the tricky one. So now it comes BCT instruction. Okay, branch test instruction. Okay, BNE is not there. So this BCT instruction, I will write it as it is here, but it shows some manipulations. Okay, 3 as it is. What about this star minus 16? This star means what? Star is the location counter value, current location counter value. What is the current location counter value? It is 24. Okay, so I will write here 24 minus the base content. What is the base content? 2. Okay, similar thing that we have done up till now. Base content. So just minimize it. 24 minus 2. Okay, now what it says? Minus 16. Okay, 24 minus 2 and this minus 16 is the constant value. Okay, so you can write like this, minus 16. Okay, so it is, I think, 6. Okay, is equal to 6. So this is the actual value, offset value for this condition, for this statement. Okay, don't get confused. This always indicates, star always indicates your current location counter. Okay, that current location counter was 24. So I have subtracted 2. Why 2? Because it is the base content value. And minus 16 is already given here. So I have subtracted minus 16. Right? So 22 minus 16, that is 6. Okay, because it is given in the instruction. And rest of the thing is same, 0 comma 15. 0 comma 15. So that is the tricky part. Means if you are solving it correctly, then you will find it easy. Okay, 0 comma 15. For the next instruction, I will write like BR, okay, branch 14, okay, nothing is given there, so write it as it is. Then yes, BR is done. Then LTORG. Okay, LTORG comes. So for LTORG, uh, what we need to do, we have to check the literal values. So literal value starts from 10, 49, 4, and at address 32, 36, 40, it is available. Okay, so I will write it as it is here. So instead of any instruction, if LTRG encountered, I need to write the constant value 10, 49, okay, and the last value was 4. Okay, completed the instruction up till now. What is the next thing now? Next thing is DC. Okay, so DC is what? DC is your constant value. So how many constant values are given here? 1, 3, 3, 4. So I will write here as it is. Okay, as compared to the previous example, this is somewhat simple. Okay, so this is the end of the pass 1, pass 2 phase. Okay, 1, 3, 3, 4. And no instructions are there because all of them are the constant value. Yes, are you getting me?
Yes, ma'am.
Okay. So here we have completed with unit 1. For your better understanding, I will just add some more examples, okay? Or I will provide you the PDF for those examples. And from the next session, we will go for